Okay, so this question is fairly straightforward. For part 1, we're supposed to write down the addition table and multiplication tables for Mod 6 arithmetic. Obviously 0 doesn't change anything, so that gives us these two rows and columns. And then we start offsetting by 1. At this point you might notice that we have these diagonals that are all the same number, and so we can just fill those in. The multiplication table is a little more interesting. And obviously the 2 column everything is doubled, so we get 4, 6 becomes 0, and so we get this repeating pattern. 0, 2, 4, 6 becomes 0, 8 becomes 2, 10 becomes 4, and so on. For 3 we have 0, 3, 0, 3, 0, 3, and for 4, 2 times 4 gives you 8, so that's 2 mod 6, 4 times 3 is 12, which is 0 mod 6, and you see that we just get this same pattern backwards. And then the 5 column just ends up being the 1 column in reverse. For part 2, we want to split each of these numbers up into a pair, where the first part is mod 2 and the second part is mod 3. So obviously mod 2 you just end up with 0, 1, 0, 1, 0, 1. Mod 3 gives you 0, 1, 2, 0, 1, 2. So it's a pretty simple repeating pattern. So the x comma y, you end up with 0, 0, 1, 1, 0, 2, 1, 0, 0, 1, and 1, 2. And of all the possible pairs, we see that they all appear exactly once. There's 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, and 1, 2. So there's a unique mapping from numbers mod 6 to pairs mod 2 and mod 3. So now we'll keep track of this mapping from mod 6 to pairs. While solving part 3, which says to again write down each table. So we start off with the addition table, And instead of adding 0, 1, or 2, etc., we are adding pairs actually. So we have 0, 0, 1, 1, 0, 2, 1, 0, 0, 1, and 1, 2. And similarly over here. So we can write the original labels above this, just to keep track. Okay, so obviously the 0 row is unchanged, so this is 0, 1, 2, 3, 4, 5, which is the same pairs as over here on the left. Then the 1 table is an offset, so 0 plus 1 just gives you 1, which is the pair 1, 1. 1 plus 1 gives you 2, which is 0, 2. 1 plus 2 gives you 3, which is 1, 0. 1 plus 3 gives you 4, which is 0, 1. 1 plus 4 gives you 5, which is 1, 2. And 1 plus 5 gives you 0, which is 0, 0. Okay, and then 2 plus 0 gives you 2, which is 0, 2. 2 plus 1 gives you 3, which is 1, 0. 2 plus 2 gives you 4, which is 0, 1. 2 plus 3 gives you 5, which is 1, 2. 2 plus 4 gives you 6, which is 0, 0. And 2 plus 5 gives you 1, which is 1, 1. 3 plus 0 gives you 3, which is 1, 0. And again, we can see this diagonal pattern forming, so we can just fill in the 0, 1, which is, all of the 4s are along this diagonal. 1, 2, which are the 5s, are along this diagonal. 0, 0, which are the 0s, fit in here. 1, 1, which are the 1s, fit in here. Then after that, 3 plus 5 gives you 8, which is 2 mod 6, so that's 0, 2. Four plus 5 gives you 9, which is 3 mod 6, so that's 1, 0. And 5 plus 5 is 10, which is 4, so that's 0, 1. So obviously we can see with this table that if you take any pair, like 3 and 2, the result is 1, 2, which is the same as adding the first digits 1 and 0 and the second digits 0 and 2. And that actually works for all pairs over here. For example, 5 and 3 is 1, 2 plus 3, 1, 0. So obviously 1 plus 1 gives you 2, which mod 2 is 0, and 2 plus 0 gives you 2, which mod 3 is 2. And this makes sense because if you take a particular number, the sum of a plus b mod 2 is going to be a mod 2 plus b mod 2. So if you know the remainder mod 2 and mod 3 of the original numbers, then you know the remainder of their sums mod 2 and 3 as well. And we can show that the same works for the multiplication table, where obviously 0 times anything is 0. So these are all 0, the first column. Similarly for the first row. And 1 times anything doesn't change it, so this is just the same labels as the top. And similarly for the second column over here, we get the same labels as on the left. Then when multiplying by 2, we simply go down this list 2 at a time, so it's 0, 0, 0, 2, 0, 1, and then back to 0, 0, because 2 times 3 gives you 6, which is 0 mod 6, 0, 2, repeating pattern, 0, 1, and then with 3 we just get 0, 1, 0, 0, 1, 0, and then 3 times 2 is 0 again, so it's 1, 0. And then 4 is the 2 pattern but reversed, so it's 0, 0, 0, 1, 0, 2. And then 5 is just the numbers descending, so it's 1, 2, 0, 1, 1, 0, 0, 2, and 1, 1. So remember, this is just taking the original table and changing all of the individual numbers to pairs. But we see here that the result of multiplying a pair is the same as multiplying the first element together and then the second element together. So for example, 5 times 2 is 1, 2 times 0, 2. So the 1 and the 0 together give you 0, and the 2 and the 2 together give you 4, which mod 3 is 1. Similarly, if you look at 2 times 4, we have 0, 2, 0, 1 gives you 0, 2. And 3 times 2, which is 1 mod 2 and 0 mod 3, and 0 mod 2 and 2 mod 3 give you 1 times 0, and 2 times 0 gives you 0, 0. So in general, we can add or multiply pairs. Element-wise. Without knowing the original number, and the result will still be valid.